Alright everyone, so this is problem 1.17 out of Taylor's Mechanics. Before I get started, please like the video and subscribe to the channel. I'll continue to do more, and it really helps when you do that. And if you'd like to suggest a problem, you can do so on Twitter at PhysicsHelping. So I'm going to try to go through this a little bit faster. I've noticed looking at the analytics, most people don't watch very long, so I won't belabor you with the details. We want to prove that the vector product R cross R is defined by 1.9, which I have here. That is R cross U plus V equals R cross U plus R cross V. So that's going to be the first thing we do. Okay. So if we do R cross, let's do this. R cross U plus V. And we start with just getting the X component of it, right? So in that case, hopefully you're good with doing a determinant. So in that case, you have Ry times, that's going to be UZ plus VZ minus RZ, and then R, in this case, it'll be UY plus SY. Okay? So that's just the determinant. And then we can reorganize this as RY UZ minus RZ UY. So that's part of it. And then plus RY VZ minus RZ VY. So when we rearrange it like that, we can see that this is equal to R cross U, the X part, plus R cross V for the X component, which is exactly what we wanted to prove. And if you wanted to, you could do the exact same process for Y and Z. And of course, you'll get the same terms. The only thing that'll change is this. Oops. So I'm not going to do that just to save us some time, but that's how you do part A. For part B, we want to prove that derivative rule. So if we take the time derivative of R cross S, these are vectors. I'm not writing vector signs, but they are. That's the same as taking the time derivative of, again, we're taking the same determinant. So we have Ry Sx, or that should be Z, minus RZ Sy. Okay. So we just take the derivative of both. These are two product rules. So we have Ry ds dt minus RZ ds, the y part, dt, plus dry dt sz minus drz dt sy. So I didn't do them quite in order. This is just the first, that should be actually a z. I don't know why I keep writing x's. So this is the first term, and then this is actually taking the derivative of this part. So I did it in a little weird order just so I can preemptively get it and reorganize it, so that way it's clear to see that this is then, R cross ds dt, that's the first part, plus dr dt cross s, which is exactly what we wanted to prove. This is for the X component, but just like with part A, you could have just as easily done it with Y or Z. You could work that out if you'd like, and you'll get the exact same result. Those are the only things that, really, change. So we were able to prove both part A and part B. If you guys prefer me to slow it down like I used to, I can do that again. But again, I notice a lot of people don't watch the entirety of the video, so I'm trying to be a little bit faster here. All right, like I said, please like and subscribe to the video, and I will make another video.